Yellow, 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 everybody. Okay, let me pause the music. Hello, hello. Hopefully, you guys can hear me. Can you give me a thumbs up if you guys can hear me, or just chat? Okay. I believe so. You can hear me, right? Hi, Wrench. I think everything is active in TryHack. Actually, VIP Labs. Do you mean like TryHack Me VIP Labs or like Hack the Box? Because TryHack Me everything is active, but like they don't put copyright strike. For TryHack Me, I can do anything. The only thing I can't do is the for Hack the Box things that are active. Those are the ones I will get a copyright strike. No, never on TryHack Me. I don't think anybody ever receives TryHack Me. There is no such thing. Is there anything good on TryHack Me which you want me to try? Like any VIP labs? TryHack Me VIP? Oh, the premium rooms, yeah. There is actually, interestingly, I'll show you. There are like, if you go on learn and challenges, subscription type, subscription only. Yeah, there are like a bunch of good ones, and there is the cloud add-on too, the one you were asking. But nothing about that. Okay. But these are the one: No Name CTF, TryHack Me, Subscribe, Doc Magic. Assuming that's okay. But yeah, it's a bunch of good ones. I know that for sure. A lot of people recommend it. Roneth, hello brother. Oh, happy Janmashtami to everyone. Yo, what rank do you get in Hack the Box ranks? I have 0 rank. I have only did like 1. On TryHack Me, I can check. At least in Canada, this month is pretty low for me, probably. My rank is 478. Pretty low. I think I was 100 last month when I was doing a lot more. But I can hit some numbers. Like, TryHack Me, I can get some pretty high up if I just put some time in. Maybe I might get chance to put some time in and get it done. And I will just do like just CTFs. Won't be that hard. You know what I want to do actually? I want to hit this one. At least in Canada, I want to hit an all time. This guy was there for like long time, and there's like now he took over. Yeah, 478. My rank is 2000 in Canada all time. If I can get this under 100, that would be cool. Maybe we can do like some long streams like in future. It just depends on the job and couple of other things, right? Like private, there is like a bunch of things. But yeah, hopefully we can hit some good numbers. At least in like by the end of the year, I can hit some. Oh wait, I'm not sharing my screen. Apologies. Okay, so I'll show you this. So when I go on compete leaderboards, monthly journal, right? My rank is 478. I don't know if it is. I don't think it's that good. But I would love to at least put myself on this board of top 50. This is a top 51. 474. I think once you start doing, you will get very high rank. Because I don't think so there's much to. What I want to do, at least, I want to achieve, at least in Canada, all-time rank in top 50. This guy was on top there for a long time. I did like a whole search, LinkedIn search on this guy. Oh, yeah, the CTF, yeah. You know, actually, what I did, I think I might have it open still. You know what I did? I stopped looking, I stopped using the the Oracle virtual box because I was like, it's very slow. I thought, you know what, I will take a chance and I will like play it. So I started looking through every single one, and I did found this guy, which was the stuff. Because I had to read through. You were right. I had to read through the CTF and saw encoded in between. So I was like, okay, this code is all junk. I know something is encoded which I don't know about. So I had to go through every single line, which I did in a fast way because I just like said, okay, this line, how many of these are there? Copy and like just kept one, kept deleting. That's all I did. It was a good challenge, honestly. I liked it. But yeah, there are 3 people who have solved it so far then. I'm coming for your seat, Vixon. Oh, Vixon is a K-pop too. But what was that? 51? Yeah. I'm coming for your team, bro. I will be coming in your team and annoying you. I think this has changed. Yeah. That's why I said it was easy and hard at the same time. Yeah. Maybe we'll do super other ones too in future. What's the scoreboard on these ones? User 51. Yo, I'm at 51. I have no idea why I'm 51. I don't know, man. You might be. So Hyperion directly at 50 and then me. You are not there. You are not there. It's hilarious. Okay, so with all those funds and stuff on the side, right? Let's do things I want to do today. One was the article you sent regarding Builder AI, which was a big bubble thing a lot of people talked about, right? And you mentioned the guy who wrote the article about Builder AI. Let me just go over here. This one. I want to read in front of everyone because it was pretty interesting. This was like actually a big blow to the stock market and everywhere, because this was like, oh, this is why AI is a bubble and everything, right? Oh, you removed yourself. Ah, gotcha. But so, and even I looked at this guy, Gergles Orozis, pretty big guy in this field and like in the world of tech info. So, yeah, I'm going to read this because I was very interested, could not do it, super tired and busy. Got busy at late night. But yeah, so let's have a look at this one. Builder AI did not fake AI with 700 engineers. Then we are going to go over crypto basics, which was part of the cybersecurity 101. And cryptography is one of my strong parts because I understand maths very well. I like it for some reason. Did a lot of it as a kid. So yeah, let's do this one. Are you guys good with this, like reading this good article first and cryptography basics, or you want me to directly go into the hacking? What's your call? How are you like? I believe this one would be fun because this, I think, affects a lot of people, in my opinion. Builder AI. So, and people who do not know what Builder AI is. Builder AI was an AI startup backed by Microsoft and a couple other people, a couple of other big players who said, yeah, it's all maths. Yeah, yeah. But yeah, let me also do one interesting thing. Let me do this way, and this way. It's all maths, man. It's all maths. It's always been maths. You know, the RSA people, the people who created RSA company, were all mathematicians too. That's why they are like so big in the game, because they were all mathematicians, big players in the industry, and also like creator of some of the biggest algorithms used in the world right now for cybersecurity. Okay, so with that being said, right, let's get back into our game. Let's see. Builder AI did not fake AI with 700 engineers. An eye-catching detail widely reported by media and on social media about the bankrupt business Builder.ai last week was that the company faked AI with 700 engineers in India. Microsoft-backed AI startup chatbots revealed to be human employees. Builder AI used 700 engineers in India. RSA algo did not make it to. Yeah, this was RSA. They made this. They made the whole thing. So 3 engineers, Ronald, Adi, and Leonard, right? So I think if you look at their last name, RSA, Rivest, Shamir, and Edelman, they are the creators of this, right? So, and they created the RSA. They created all the RSA algorithms. They didn't lie to AI. They didn't lie. AI is actually actual Indians. Yeah, That was the, I think, Fireship video too. It was like AI means another Indian. But it was interesting, right? So it was like an interesting case because if they were, because Microsoft it does its due diligence, right? Looking into AI and stuff, and they didn't look at the code or anything. They gave money. Hard to believe. So Builder AI, faked AI with 700 engineers, now faces bankruptcy and probe. In the past week, I have been talking with several engineers who worked at Builder.ai, Builder.another Indian, and can confirm that this detail was untrue. But let's hold that thought for a second and do a thought experiment about how we could make this headline be true. Something like it has been attempted before. And okay, design challenge. A system with 700 developers or devs pretending to be an AI. Very hard to do, right? Like 700 people able to like show a engine which is like being used by millions of people. Very hard to do. Okay, we put on our evil hacker villain mask and put ethical considerations in the bin. Our goal is to build a system where 700 engineers pretend to be a working AI system with all without using any artificial intelligence. Also, is the year 2024 in this experiment, so how could we pull it off? A native approach. Have the devs write code and assume there will never be more than 700 parallel sessions in place. So basically, not more than 700 people at one time will be asking an AI or playing with their AI. So user submits a prompt, right? Create a to-do app, add a way to upvote to-dos, select developer who is free, pull a pool from 700 developers, right? Pretend to be AI. Start typing out the program and return the first version. 10 to 30 minutes. Hard to do. Hard to create an app within 10 to 30 minutes. And after 10 to 30 minutes delay, again one. So first attempt at a system where 700 developers could pretend to be or can pretend to be an AI. What is he using? Pragmatic engine. Okay. There is one immediate major problem. Latency. No user will believe it's a working AI if it takes 10 to 30 minutes to provide a response. In that scenario, the deception is likely to be quickly exposed. What's needed is faster response times, so customer could be fooled into believing they are interacting with a machine. Basically, what's called for is something akin to mechanical Turk. What is that? Mechanical Turk, also known as automation chess player. Ooh, I have seen this image so many times. Or simply the Turk was a fraudulent chess playing machine constructed in 1770, which appeared to be able to play a strong game of chess against a human opponent. That's hilarious. I think that's actually an interesting word to keep into your dictionary with the AI coming in. Okay. The mechanical trunk, also known as automation chess player, we read this, okay, was a fraudulent chess player machine constructed in 1770, which appeared to be able to play a strong game of chess against a human component. For 84 years, it was exhibited on tours by various owners as an automation. The machine survived and continued giving occasional exhibitions until 1854, when a fire swept through the museum where it was kept, destroying the machine. Afterwards, articles were published by a son of a machine's owner revealing its secret to the public, that it was an elaborate hoax suspected by some but never proven in public while it still existed. Wow. That's actually crazy. People are crazy. Automation chess player concealed a person inside the machine, which... Idor, good morning. Good morning. How you doing, brother? So, automation chess player concealed a person inside the machine, which went unnoticed for more than 80 years. Hard to believe. I got into college for PG. Oh, nice. Congrats, bro. Everybody, congratulate our boy Idor for getting into the college. That's awesome. We were talking about it on the Discord, right? MCA for cybersecurity. That's awesome, man. What's that? Oh, nice. Masters of Computer Applications. Nice, bro. I will do OSINT. Nice. So it's nice, man. That's awesome. Masters of Cyber Application is good. Like those application ones are very useful. Hey, Panda. Howdy ho. Howdy, howdy. How you doing? Okay, going back to our stuff, right? So, back to the current problem and applying the inspiration from the 18th century chess machine containing a concealed human. Panda, you will like this. Um, Mechanical Turk. You will like the story because I know how much you like it. We said 4 is pretty solid for viewers. Yeah. Dude, I'm very happy with 4 too. Yeah. We got, yeah, YouTube we have 4. Twitch we have 4. I'm happy with it. Thank you. So, back to the current problem, applying the inspiration, 18th century machine, to improve latency and decrease user suspicion, we could perhaps stream what the sign developer typed. Okay, start typing out the program. Characters appear every few seconds. That's simple, almost simple. This is better, but it remains a giveaway that the system is slow to complete a basic task. So, what about incentivizing our developers with a bonus for completing tasks under 3 minutes and allowing them to use any tool they want? Incentives are powerful, so it's likely the following would be observed. Oh, Amrita Vidyapeeth Coimbatore. Oh, nice, man. Congratulations. I'm happy for you, but I want some big things coming out from that. Okay, so we have 90% of the task completed within 3 minutes or less. They can use any T2 college. That's big, man. Tier 2, that's big. Right? And if you're doing application, it's a good thing, man. I'm very happy for you. I keep doing that. AVVC. Pretty much, yeah. This is the name, boss. Okay. Developers complete tasks much faster when they can use any tools they have, right? And their T to the T2. T2 means tier 2, bro. T2 is like tier 2 college. So there are certain levels, like Harvard. If we talk about like world, Harvard is considered like one of the top universities. So they are tier 1. Then there are tier 2, tier 3, and other ones. So like how good a college is, like in India it would be IITs and stuff. NITs will be tier 2, right? And other ones. So that's how the hierarchy to tell how good the college is. And we did it. We managed to fake a good enough AI. But wait, how exactly did the developers complete their tasks within the arbitrary time frame of 3 minutes? To find out, questions are asked, and this is what we see. Remember, it's 2024. So pass a prompt, ChatGPT or Claude, they were using like a wrapper. And majority of the companies, I will tell you this, in AI right now, majority of the companies are just wrappers. So this is a wrapper. Basically, they are creating, let me show you the whole world of AI right now. Expose it in front of you. So let's say I start a company today, right? I am making a video company. Video AI. What happens is you give it a prompt, right? My company will go to, let's say, VO3, which is Google's, right? And it has its own special prompts, right? A better prompts. You as a user, a common user with not much of technical knowledge, are going to just say, hey, create a animation of, let's say, like SpongeBob SquarePants on this joke or blah, 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 right? On this political issue or whatever, right? It has some special prompts and it's going to use its special prompt SP plus your input, right? To VO3, right? Make couple of those requests. It gets back and then it sends you the result. This is called a wrapper company. Basically, it's using either Google, OpenAI, the ChatGPT things, Meta's Llama, all those AI, but they are just using special prompts as a wrapper. They are wrapping already existing AIs to give you that. And that's why a lot of these companies, every time a change happens, right, there is a good enough chance they all can go bankrupt any day, because this we have seen with Twitter. Oh, Twitter, and this is like, you guys can go over and I can prove it too. Bunch of companies was relying on Twitter's free API, right? Because it was free for developers, free for like researchers and stuff. AI security platform LinkedIn. Yeah, I would love to. Thank you, man. Wrench, thank you so much. Please do. So, or Twitter or X, right? Before Elon Musk took over, right? They had a free API, and my couple of my friends were creating an AI for cementing models, and that was like 2020s, before even ChatGPT was like famous and stuff. They were using these developers, researchers, free APIs, and there was a lot of credits. Company used them, right? Elon Musk came and said, nope, my platform, my rules, my life, my rules, right? You have to pay. Guess what happened? Majority of the companies who were multi-million dollar companies went like this down. There were a lot of complaints about those things. Like, some were good companies. I won't say companies like were good, because if they're using money. Some were like about cyberbullying. Some were about like Twitter like analysis, SEO and all those stuff. So all of them gone within one day, because they relied on those free APIs from Twitter. And that's why Twitter was like losing money left and right. So this is same thing, right? They are using APIs to create a service, give you a service. Same thing here. They are using some or the other AI in the world to give you a service. That's what's happening in the world of AI right now. And I have seen it with a couple of big tools. Not even kidding. So wait, what? Developers pretending to be an AI would use an AI to deliver the outputs in time. This is a logical approach for 2024, when LLMs were already more than capable of generating high quality code. And this is why it would be irrational to hire 700 developers to pretend to be an AI last year, when there were already LLMs that did this much better. If you hired a competent engineer in 2024 to design a system that takes a prompt and pretends to be an AI, and they could use any tool they liked, and there were 700 developers for the project, what they build would look something like this. To do app, it will basically be a chat GPT. They don't need a developers, right? Spoiler, Builder AI did exactly this. Natasha's tech stack, right? First showcased the idea of Natasha in 2021, well before ChatGPT was announced. Back then, Natasha was positioned as the personal app builder, and it was clear that the solution worked with a network of geeks who built apps to spec. You tell us your idea, and me, the AI, Natasha, and my network of geeks built it using building blocks that really work. So basically, there were good AI developers, or not the AI developers, AI prompt engineers. The product promised a cost estimate upfront and a schedule. The idea was that by taking on thousands of projects, the team behind Natasha would create reusable building blocks that speed up building websites and mobile apps. In December 2023, 1 year after ChatGPT was released, Builder AI announced Natasha CodeGen as your always-on software development partner. In 2024, company Demood, what's that? Demood, record to demonstrate the capabilities. Okay, demonstrate the capabilities. Okay. The company demonstrated the capabilities of Natasha CodeGen in a series of videos which show code generation happening. Please AI, get better and take my job. Damn bro, don't say that, man. Not for me. Yo AI, it's a wrench, not me, man. Don't take my job. In the video, there is a cut and the video returns when the React code is generated. I have confirmed with former engineers at the company that behind the scenes, the system ran for a few minutes before finishing code generation. This is interesting. Like, they're using proper CLI tool. Orchestrator, service admin production, logs, orchestrator, service, I don't know. Interesting. Natasha was aimed to be an AI tool for this whole software development cycle: idea planning, code generation planning, testing, generate code, create a PR. PR is pull request, GitHub. A team of 15 engineers worked on Natasha CodeGen. Most engineers were based in UK with around 3 in India. That's interesting. That's very hard to see if there is like more engineers onshore. Onshore is like, basically US, UK, all those companies where big clients are, and offshore is like companies like places like India, developers in India. Because I'm an onshore employee for Infosys. At its peak, Builder AI team was circa or around 30 people. On top of building Natasha, the team was building and maintaining many AI products and services. One ex-engineer there told me they thought a lack of focus contributed to company's demise. Tech stack behind Natasha: Python, Ruby on Rails, React, GPT, and Claude LLMs. So basically, okay, the team built a set of coding benchmarks that they ran whenever a new model came out and chose the model that worked best for their use case. Interesting. So they created their own benchmarks. How would you, like, if you are given a choice, like, how would you create your own benchmark? That's crazy. Natasha granted vision and just code generation, blah, blah, blah. Code name for all AI projects inside Build AI, like Microsoft using Copilot for all its AI projects, not only GitHub Copilot. Other products using Natasha brand name, a chatbot, knowledge graph, machine learning models. What about 700 developers? Had working code, Builder AI had working code generator platforms built by around 15 engineers. So why did it need to hire hundreds more in India? For one thing, Builder hired 300 internal engineers and kicked off building internal tools, all of which could simply be purchased, including Builder Home. So basically, they created tools that were like could have been used. So they were like regenerating or rebuilding Word, PowerPoint, and stuff, similar to Jira, Zoom, inspired based on Figma, Slack, SenseiBot, which is interesting. They could have like used so many available tools and just integrated AI with it. Just like I think, what's that name? Cursor did using Visual Studio Code. One reason Builder AI failed to grow revenues as quickly as investors were told it was doing was likely due to its lack of focus and rebuilding tools that already existing without building anything novel. So there was nothing extra they were building. Also sold an external development network on top of Natasha. Interesting. So basically, Builder AI, okay, they have their own IDE. Was that the primary bottleneck was that blah blah blah, and get all the email password. Yeah, dude, it's crazy. So downfall, like basically, what I get the idea is they hired a bunch of people thinking like we will create a whole suite like Microsoft and stuff. Like they will do their own. Like, there is another company, right? I don't know if you have heard of it. Zoho have their own like bunch of tools, just like CRM ones, which is like similar to Salesforce, and a bunch of like Outlook, similar to Outlook, their email and stuff. And they have been in a long time. They have been in the game for a long, long time. But their service I didn't like much. Zoho I didn't like much service. I've used it, didn't like it. So they were trying to build provisional account to its auditors, showcasing large reduction to prior revenue estimates. According to people familiar with the matter, these figures showed a prior estimate for 2024 revenue have been revision. Oh, so they like thought it is same as Byju's. Same as Byju's. Again, same thing. Dude, I will say this, like, not going to read the whole thing, right? Because I think I got the idea of this, what exactly is, and trust me, if you have subscription, let me do this. Trust me, if you have subscription to things like Forbes, all these big ones, newsletters, and these magazines, fucking cancel it. That's all. Because every time you see, there are so many people who Forbes said, "Oh, amazing person," blah blah blah, bullshit. Reality is, they nobody do a proper check, especially in the media industry, and they claim that they know everything. And like, it's just everyday thing. Same thing happened with that like girl who was considered as Steve Jobs with the blood sample thing, the Silicon Valley BS. And to avoid the jail time, she became pregnant. World is wild. Did he share? Okay, so that was it. I think for Builder AI. What now we will do is complete this. We have like almost an hour of streaming, so let's try to complete cryptography basics. My strong points. So feel free to ask me any questions. I'm very good with crypto. I feel like she's a stealer. A stealer. What's a stealer? A stealer. What was that? Silicon Valley fraud blood Theranos, whatever that is, right? She became pregnant just so she can avoid some stuff, and the whole industry was like, "Oh, amazing, amazing! Everything is a stealer." Yeah, yeah, yeah. And bro, like, think about it, right? So many companies, Forbes, Fortune, Inc. All these are like all BS companies. Like, we are paying hundreds of dollars to them. Like, they're making hundreds and millions, right? They are billion-dollar companies, right? And they do shit like this. Yeah, yeah, yeah. She was a thief. Like, she was not even a thief. Like, if you see her story, she understood like developers are idiots. Sorry, investors. A bunch of them. You show them some numbers, idiots. They will like happy to run and see, oh, money can be made. Greed is like a very bad thing. Like, it can make you blind with two eyes. So you won't believe other people are telling you the truth when you are blind. And that's what she was. She just showed everybody greed and it was able to take their money off. Simple. But okay, all that aside, cryptography basics, baby. This is one of the best ways to actually start into hacking. Greed is pretty good thing for me. Nope, I don't want a hint. Sure, 50%. Okay, greed is good. That's epic speech. Okay, but to anyone, right, who wants to $50 hint. Okay, no, $50 hint. That's like sarcasm right there. But to people, right, I will say this. A big reason why I'm very happy and I'm like I was like a very interested always in cybersecurity. A good way to also start is cryptography basics, because it helps you build and like easy to build like some small stuff you can see by building your own GitHub projects and stuff, and see how you can do things and how security makes a big difference in your life. So let's learn the basics of cryptography and symmetric encryption, right? Introduction. Have you ever wondered how to prevent third parties from reading your messages? How can your app or web browser build a secure channel with a remote server? By secure, we meant that no one can read or alter the exchange data. So I am sending data to you guys, right, on this chat here. How these companies like YouTube or Twitch make sure that this is not getting altered in between. That's your security. One sec. Okay. Furthermore, we can be confident that we are connecting with the real server. Thanks to cryptography, these requirements are satisfied. Real server, which means is like when I go to hack the try hack me or hack the box, how do they make sure this security, this certificate, that's also encryption, right? This communication. So cryptography lays the foundation for our digital world. While networking protocols have made it possible for devices spread across the globe to communicate, cryptography has made it possible to trust this communication. This room is the first of 3 introductory rooms about cryptography. There is no learning prerequisite except basic abilities to use Linux command line. If you are not sure, please do the pre-security one, which we did, right? Linux Foundation. Cryptography basics, this room. Public key cryptography basics, which is good. Hashing basics, which you will use actually to see and crack the hashes with the Active Directory and stuff we did earlier. Learning objectives. Upon completing this room, you will learn the following. Cryptography key terms, importance of cryptography, Caesar cipher, a very old one, standard, and I think it came from the time where Caesar was alive. That's why it's called Caesar cipher. Standard symmetric ciphers, common asymmetric ciphers, basic mathematics commonly used in cryptography. Okay, so let's get started. Oh, I never heard a volume from here. Interesting. Importance of cryptography. Cryptography, Cryptography's ultimate purpose is to ensure secure communication in the presence of adversaries. The term secure includes confidentiality and integrity of the communicated data. What was that sound? I think it's when I did like my first one, right? The 1 day streak. I think that was the sound. This is my first time hearing it too. Yeah, it's very new. I never heard it. Cryptography can be defined as the practice and study of techniques for secure communication and data protection where we expect the presence of adversaries and third parties. So basically, practice and study of techniques for secure communication and data integrity. In other words, these adversaries should not be able to disclose or alter the contents of the messages. Cryptography is used to protect confidentiality, integrity, and authenticity. So if you see, this is called CIA triage: confidentiality, integrity, and authenticity, or some people say in availability. In this age, you use cryptography daily, and you're almost certainly reading this over an encrypted connection. So you see here, when you go, you see that lock symbol here, right? So a connection details connection is secure through cryptography. So consider the following scenarios where you would use cryptography. When you log into TryHackMe, your credentials are encrypted and sent to the server so that no one can retrieve them by snooping on your connection. So nobody, let's say, listening to my connection through Wireshark or something can listen to these. When you connect over SSH, your SSH client, secure shell, secure because it's encrypted, and the server establishes an encrypted tunnel so no one can eavesdrop on your session. Again, with the Wireshark, right? If somebody able to get access to my Wi-Fi and stuff. When you conduct online banking, your browser checks the remote server's certificate to confirm that you are communicating with your bank server and not the attacker's one. When you download a file, how do you check if the downloaded correctly? Cryptography provides a solution through hash functions and confirm that your file is identical to the original one. What that means, I think I can show you quickly. Kali Linux. So if you download, like go to the download images, right? Let's say I go to the virtual image and I want to do, you see the sum? This is the hash value. And when I download this file, 3.2 GB file, I can create a SHA sum of this and see if both have the same sum. If they do, then yes, my file, the Kali Linux I downloaded, the image is not corrupted, basically. As you can see, you rarely have to interact directly with cryptography, but its solutions and implications are everywhere in the digital world. One sec. Consider the case where a company wants to handle credit card information and process related transactions. Yo, no, no. If anybody is looking at this, do not do this. Wrench is just having fun. Base 64 is not cryptography. It's just encoding, decoding. Like you can decode it easily, man. Okay. As you can see, you have to interact directly with cryptography, but its solutions and implications are everywhere in the digital world. Consider a case where a company wants to handle credit card information and process related to transaction. When handling credit cards, the company must follow and enforce the payment card industry data security standard. So this word you will see a lot. PCI DSS stands for the payment card industry data security standard. A lot of companies, it's a hard thing to do, right? And that's why you see a lot of companies rather would use something like Stripe to help them with this. In this case, the PCI DSS ensures a minimum level of security to store process, and transmit data related to card credits or credit cards. If you check the PCI DSS for large organization, you will learn that the data should not be encrypted both while being stored at rest, or should be encrypted both while being stored at rest or while being transmitted. So whether the data is being sent by me to the server or from one server to another server, right? All that and even if it's on the server database, it should always be encrypted. So data is encrypted during motion and at rest. You guys can read this. I don't think I want to read this. How much is it? Yeah, read it, lads. 37 pages. Not bad. All the best. Cheers. You can thank me later for sending this. Okay. In the same way that handling payment card details requires complying with the PCI DSS, handling medical records requires complying with their respective standards. So you might have heard of HIPAA, right? We'll talk about here, or even based on various countries or jurisdictions, even at state level, it changes, right? In US, I think is HIPAA. In I think GDPR is in European Union, and in Canada is different, stuff like that. So unlike credit cards, the standard for handling medical records may vary country to country. HIPAA is a US thing, yes. Example, laws and regulation that would be considered when handling records include HIPAA, Health Insurance Portability and Accountability Act, and HITECH, Health Information Technology for Economic and Clinical Health in the US. So HIPAA and HITECH, both are US, like Ren said. GDPR, General Data Protection Regulation in European Union. So all the countries that are in the European Union are following this one. DPA, Data Protection Act in the UK. Although the list is not exhaustive, it gives an idea about the legal requirements that healthcare providers should consider, depending on their country. These laws and regulations show that cryptography is a necessity and that should be present, yet usually hidden from direct user access. So what it's saying is basically all this type of encryption, right? When you are going to a doctor or stuff, these medical standards, these encryption, cryptography is in use, you just don't know, right? Same like when you are going on this website or you're looking at me, right? Encryption is there. What is the standard for handling payment card, right? I think I'll just do it. No need to ask. Okay. Plain text to ciphertext. This is where our stuff starts, I believe. Let's start with an illusion before introducing the key terms. We begin with the plain text that we want to encrypt, right? Our secret password, something like that. The plain text is the readable data. It can be anything from a simple hello, a cat photo, a credit card information, or medical health records. From a cryptography perspective, these all are plain text messages waiting to be encrypted. The plain text is passed through the encryption function along with a proper key. The encryption function returns a ciphertext. The encryption function is a part of the cipher, and a cipher is an algorithm, basically your encryption algorithm, to convert a plain text into a ciphertext and vice versa. Hear me out again. Listen to this very carefully. A cipher is an algorithm that converts plain text into ciphertext and vice versa. Hashing is not same. Hashing plain text into a hash, not vice versa. There is no like return one. And that's how this game works. So we have a sender with plain text, let's say hello, or our information. We put a key, our password or anything, goes to the encryption algorithm, and a ciphertext come out, the main thing we are looking for. To recover the plain text, we must pass the cipher along with the proper key via decryption function. So encrypt, decrypt, which would give us the original plain text. This is shown in the illustration below. Same thing. We have just introduced several key terms and we need to learn them to understand any text from cryptography. The terms are listed below. Plain text is the original readable information or data before it's encrypted. So the plain text, non-encrypted data, the original one, can be anything, document, information, blah, blah, blah. Ciphertext is the scrambled, unreadable version of the encryption after encryption. So your plain text went through encryption, comes out is the ciphertext. Cipher is the algorithm, the encryption algorithm itself. Key is your special key that you use to encrypt or decrypt data. In general, the use cipher is public knowledge. However, the key must remain secret unless it's a public key in asymmetric encryption. There are asymmetric, if you are confused, don't worry about this, but there are like certain times when there are two keys, public and private, basically. Encryption is the process of converting plain text into ciphertext using a cipher and a key. Decryption, reverse of encryption, converting ciphertext back to plain with the help of a cipher and key. What do we call this encrypted text? I will say ciphertext, right? Oh yeah, it is that sound, man. It is that sound, wrench. What do you call the process that returns the plain text? Process, remember. Okay. And this is fun. Now this is fun. And you will see if you take any encryption like starting here, this, I believe I read it too during my university time. It is a musical, yeah. It's interesting. They added it, I think, in last couple of days only. Okay. Cryptography's history is long and dates back to ancient Egypt in 1900 before Christ. However, one of the simplest historical cipher is the Caesar cipher from the 1st century BCE, before Christ, or BC, right? The idea is simple. Shift each letter by a certain number to encrypt the message. Consider the following. We have plain text, try hack me, key is 3. Cipher would be, and cipher basically the best cipher, I guess so. So cipher is basically the algorithm, Caesar cipher. You can easily figure out that T becomes W, R becomes U, and Y becomes B. No one can decode it. Indeed, it's hard to know. It's actually funny, right? Like wrench, people might even use it right now and we would be like scratching our head what they did. Use it in your DB, all the devs. Yeah, use it in your production DB. Hard to decode. As you notice, once we reach Z, we start all over, right? So let's say if Z was used, right? 3 keys. So after Z, we'll start with A, B, and the word Z will become C. A becomes D because 3, skip 3, right? So as shown in the figure below, consecutively, we get the cipher W, U, B, K, D, F, and blah, blah, blah. So basically, X becomes A, Y becomes B, Z becomes C, A becomes D, blah, blah, blah. That's cipher. So how it works, A, just in case if you didn't get it. If the key is 3, remember, A, if something is should be written as A, it will skip 1, 2, 3. It will become D. B will become E because it's 3. Remember that. That's all cipher is. Caesar cipher is. And you can decrypt it by like going back. Okay, D, the key was, okay, going back 1, 2, 3 should be A. That's what Caesar cipher is, but it's interesting to know that it was very hard for its time. For encryption, we shift to the right by 3. For decryption, we shift to the left by 3 and recover the original plain text as illustrated in the image. However, if someone gives you a ciphertext and tells you that it was encrypted using Caesar cipher, recovering the original text would be a trivial task as there are only 25 possible keys, right? Because from A, the max you can just go is to like, okay, 25 letters, right? There are total 26. So you can convert A to Z, B to let's say A again and stuff like that. And it's a very easy to go out, like 25 keys you will be able to figure out. I think you don't even have to do much. is this one, like I believe this might be this or something like that. Yeah, so it's very easy. In English level, it's very easy to find, right? If you see key, this is Alpha Bravo. The English alphabet is 26 letters, and shifting by 26 will keep the letter unchanged. So A after 26 will become A. Hence, 25 valid keys are available for encryption with Caesar cipher. The figure below shows how decryption will succeed by attempting all the possible keys. In this case, we recovered the original message with key 5. So basically, this was the message. This is Alpha Bravo contacting Tango Hotel Mike. Right? Hopefully, you guys can see this. So, how would you would come across many more historical ciphers in movies and cryptography books? Example include Wigner cipher. Enigma is a big one. Everybody should check some videos on Enigma. This is where, like, I will say encryption peaked very fast for its time. The 1' pad was also a very interesting thing, but very unfortunately, it's once you get, like, it has one big issue. So have a look at these two ones. You will like it. This one you can ignore. Knowing that this was encrypted using Caesar cipher, what is the original text, lads? Do you want me to do with the AI? Let's see if AI can do it. Let's see if AI can do it. I can encrypt. I could have done it faster though. Yeah, AI can do it, man. I have made a tool for doing this stuff for our CTFs. Oh, nice. So I know next time I see your CTF, like common cipher stuff, nice. Okay, so type of encryption. This will be interesting, and this is where you can make some notes. The two main categories of encryption are symmetric and asymmetric encryption, right? Let me just put in my notes. Symmetric encryption. Symmetric encryption, also known as a symmetric cryptography, uses the same key to encrypt and decrypt data. This is what you have seen majority of the time. As shown in the figure below, keeping the key secret is a must. It is also called private key cryptography. So basically, if this is your encryption, this is your encryption algorithm, you put your text, and when I say text, it's basically plain text, and you put your special key, private key. This only takes one key, private key, and give you the encrypted data. Okay, so this important to know. Why it's important to know, you will see in a bit. Furthermore, communicating the key to the intended parties can be challenging, as it requires a secure communication channel. Maintaining the secrecy of the key can be a significant challenge, especially if there are many recipients. The problem becomes more severe in the presence of a powerful adversary. Consider the threat of industrial espionage, for instance. Because let's say if somebody finds your passwords, right? Game over type thing. Alice wants to send a cipher text to, let's say, Bob with the shared key, right? They shared the key. Let's say the key is bagels or sandwich. Now somebody else heard it. Game over. Consider the simple case when you created a password protected document to share it with your colleague. You can easily email the encrypted document to your colleague, but most likely you cannot email them the password. it's a very important thing you need to understand, and this is what a lot of people make mistakes. Never ever send your encrypted data plus its key through the same medium. Like, let me put it, same medium. Probably one of the first things as I learned and I was taught when I was in industry, never through the same medium. What it means, let's say if I'm sending this through email, I will send this through text message, right? Through WhatsApp, through like a actual like postcard, but not through the email medium. How you travel or the data travels, right? Never ever use the same communication channel, communication medium, right? That's very important for you to understand. Where I have seen people do it, and that's a big reason why things like go bottom. So that's why never do this. The reason is that anyone with access to their mailbox, right? Anybody who was able to hack your mailbox would access both the password protected document in its password, right? Use same password everywhere. Wrench is having fun, man. Therefore, bro, like, do you really give these advice or you're just having fun? I'm really curious. You are just making the world insecure so that other people can do it. Password would be your name and birthday of your dog or the dog's name. Holy. Wrench. Therefore, you need to think of a different way. That is, channel to share the password. Unless you think of a secure accessible channel, one solution would be to meet in person and communicate the password to them. Probably one of the best ways. Example of symmetric encryption are DES, data encryption standard, or triple DES or AES. Now let me give you a reality of how big encryption was when it was, right? And why. Data encryption standard was, and I did a whole research of this. Like, I was obsessed with DES and triple DES because of his political history than anything else, right? And you need to understand that's why APTs, the advanced persistent threats, are advanced persistent threats for a reason, and I will show you today. DES, developed by IBM in 1970s. If you search, (1970s) by IBM. So I know the things, right? It was by IBM, but IBM, just like Dell, when what was the name? Edward Snowden exposed. It was Dell working with the NSA. This time it was IBM in 1970s working with the NSA. NSA came to them and said, "Hey, create a very strong. Yo, man, you should do crypto hacks." Yo, I would love to. Actually, my first hack was a crypto hack on Hack the Box. My first hack was a crypto hack. I would love to. We can do some crypto hacks. I would love to. Those are where I peak, or I can peak. But what I want to share is, right, it's very important for you guys to know. And this is where this is going to be pure cinema. This is going to be pure cinema next 5 minutes. Give me a chance. Crypto hacks is a platform? Okay, I'll keep it in mind. Okay. But I want to give you guys what exactly happened, right? 1970s. Computers was just becoming a thing. NSA went to IBM. IBM was big. IBM was, let me go like, IBM, how big was IBM? IBM was like, think of it as Microsoft, because there was no Microsoft by then properly. It wasn't established. There was no Apple, right? That's why it was all IBM. Because Apple became a thing in 1980s, right? And same with Microsoft. But here was only IBM, the big guy, the biggest guy in the game. So IBM, they went to IBM and said, "Hey, give us a very strong encryption, right? That it takes years for anybody to hack." They came up with DES. And What did the government said? And this is like something where you need to understand what government do is crazy and never trusted. Government tell US government US government told the whole world to use DES because it is the most secure encryption standard. Nobody can hack your password. Nobody was able to tell how you can hack it and stuff like that. So fully secure. Now, reality. This is all bullshit. Why? Because one of the things that this happened when they were talking, right? When government was talking with IBM, this area here, they said, hey, create one backdoor. Amin Khalif, thank you so much for following, mate. Thank you so much. But yes, going back, right? Fully secure, right? They said create a backdoor. So, US government is going to secure everyone. Sure, it's fun. But so they said to create a backdoor, and this never came out publicly. It's very hard for you to find, and I will show you where I found it. Because I was super obsessed with the ES. Created a backdoor, and I think it was called Heartbleed. What concept are you explaining? Bro, I was talking about cryptography basics. No, see... I was talking about cryptography basics, specifically symmetric encryption, and the word DES came. So I wanted to give you guys a big example of why I like cryptography so much, because of the political history is crazy. Just like Enigma, right? Enigma was a big thing. And the person who actually helped Enigma was killed. I don't know if you guys know about Turing. Alan Turing, right? The guy helped with Enigma, and he was killed by the so he helped stop Germans, right? He was a brilliant scientist. He helped break Enigma, or the Nazi code, right? Cracked the Nazi code and created even a stronger encryption. But because he was gay, he was given a poison apple by the UK government, who he helped, and they killed him because he was gay. So a lot of history, man, a lot of blood history, legit, with this. This topic is the one with in computer science, in hacking, I will say, is one with the most blood, or biggest line of blood history. So I think it was called Heartbleed, the backdoor name, if I'm not wrong. Heartbleed. What was this backdoor, right? And if you want to go over like what exactly is this, this is my name, DES zoom info. Why I am here? What the hell, bro? Why there's so much people, so many names? Okay, holy, never search your name on. So DES, I think I have it somewhere in my name. Open source contribution guide. No. Kibana, Elasticsearch, DS practice. Nope. You have to see this. So DES 441. This was the course name, and I created a whole DES algorithm. Talked to some big guys, right, in BlackBerry and stuff. And here's probably the link. So this is the link to my report I created. Heartbleed blog. There is a full site on it. Yeah. See, you know it, right? And I will show you. So I created a whole thing, right? This is my name here. My name, Gaurav Satija, right? Professor, TA, right? I went through every single step. I created everything. So what happens? There are 16 plus steps. There are 16 rounds of this encryption happens. That's why it was pretty secure, quote unquote. I think everybody knows it. No. It's interesting. Majority of the people don't know. And I will tell you this. So backdoor, NSA, damn bro, is cooking. Yeah, I am cooking today. I told you, this is my game. Cryptography is my game. I will tell you this right now. So NSA created this backdoor Heartbleed, right? Which means majority. Remember, I said like there are it uses matrix multiplication or some matrices to do some stuff. So majority of the matrix were basically had a backdoor, except for one, right, which was hard to like find. So what NSA did was like they knew about this, and why they did this, why they went through a whole saying this is the most secure one, why they like said it's fully secure when it wasn't, because they wanted USSR, not Russia, USSR, to use this DES, right? They created this to tell, hey, if you want USSR not to see your stuff, use this algorithm, but they put it publicly out. But when their game was that USSR also uses it. Good for us then. You will be our crypto guy. We are pretty weak in crypto. I would love to, man. I would love to, right? So this guy, they were betting that USSR will use DES for their communication, and these people will outsmart them and find whatever it is, right? Find the secret. Now here the game changes. USSR knew about the Heartbleed. USSR knew about this. They had their own scientists or they had their own spies in the government able to find it. So they came up, they never used DES that way, right? And that was the whole story. And how I can promise you that it was, because DES creator, one of the guy name was Don. I don't remember the exact name. Where is this? Yeah, Don Cobbersmith, right? This guy was one of the big cryptographers for IBM when it was being coming out, and it's called S boxes, which had the issue. And one of the scientists, right, one of the big cryptography scientists from Germany, talked to Don Cobbersmith, like I think in 2005 or 8, somewhere around that, right, a decade ago, and he did said, we knew about the backdoor, we created it intentionally so NSA could hack and find about USSR communication. But they never said it publicly. So this is a beautiful history of why cryptography is so fun, because it has like so much politics, so much brain power, and so many things going all together at once to like just like get a edge over each other. That's how the game is of cryptography. Good for us, yeah. So just wanted to go over like this, and that's why triple DES came and AES came from this. So have a look at that history, amazing history. So DES was adopted as the standard in 1977 and uses 56-bit key, 56-bit key with the advancement in computing power in 1999. A DES key was successfully broken in less than 24 hours. So computing, it took 20 years for them to break DES within 24 hours, motivating the shift to triple DES, because they thought if DES it is 24 hours, 24 times 24 24 hours long. Bullshit. Triple DES is DES applied 3 times consecutively. The key size is 168-bit because 3 keys were used one by one. Though the effective security is 112 bits, triple DES has more of an ad hoc solution, when DES was no longer considered secure. Triple DES were deprecated in 2019 and should be replaced by AES. However, it may still be found in sub-legacy system, right? How triple DES, like if you think of DES, triple DES was same thing. Basically, you put your key here, key 1 goes, key 2 goes, key 3. So it was pretty much DS, just going to say. AES was adopted as a standard in 2001 and its key size are 128, 192 and 256. Going to say this out loud, don't use AES. Use RSA 1024. There are many more symmetric encryption ciphers used in various applications. However, they have not been adopted as standards. Doesn't matter what USA says, doesn't matter what Russia says or any other government says. Use what the community says in general. Right? Use AES best thing. Nah. Never. Don't use AES, man. I'm just going to say it out loud. Don't use AES. So that's what basically is a symmetric encryption where only one key is required to first encrypt and same key is required to decrypt. Now, asymmetric encryption. Unlike symmetric encryption, which uses the same key for encryption and decryption, asymmetric encryption uses a pair of keys, one to encrypt and the other to decrypt, as shown in the illustration below. To protect confidentiality, asymmetric encryption or asymmetric cryptography encrypts the data using public key, hence it is called public key cryptography. Right? So Alice, plain text, Bob's public key. Bob can give to the whole world, hey, this is my public key, send this to me, right? And because only Bob has his private key, only he can, or I believe Bob is a man, so he can decrypt this. Only he can decrypt this. Nobody else, because he has the private key. Examples are RSA, Diffie-Hellman, amazing, again. Elliptic curve cryptography, I never understood this one, probably have to go again. So RSA and Diffie-Hellman were really good ones, and RSA is the standard. I hate Bob and Alice. The two keys involved in the process are referred to as public key and private key. So if you actually go to some of the people's like profiles, right, or specifically journalists, what they did, right? They make things secure. Okay, that's why you hate Alice and Bob. So journalists, right? They will say, hey, my public key on their blogs or anywhere, right? If somebody wants to share some information to them, this is their private key, and this is the algorithm or public key, and this is what the algorithm they want you to use. Algo. Then let's say RSA. So if you want to expose some scandal, if you want to do something, this is the way you do it. A very beautiful way, in my opinion. Data encrypted with public key can be decrypted with the private key. Your private key needs to be kept private, hence the name private key. One sec, I'll drink some water. Asymmetric encryption tends to be slower, and many asymmetric encryption ciphers use large keys than symmetric encryption. So remember, it's slower, but it's better. And many asymmetric ciphers use large keys than symmetric encryption. For example, RSA used 2048, 3072, right? One time we were talking about 128. This is at like 10 times bigger. Or actually 20 times. 2048, 3072, 4096. And 2048 bit is the recommended minimum key size. Diffie-Hellman also has a recommended minimum key size of 2048 bit but uses 3072 and 4096 bit keys for enhanced encryption. On the other hand, ECC, elliptic curve cryptography, can achieve equivalent security with shorter keys. For example, with the 256 bit key, ECC provides a level of security comparable to 3072 bit RSA key, which is big, right? And it is related to the curves. I don't know what's the name. Quadratic formulas. That's where it came from. Quadratic formulas. The reason I hate it, gives me PTSD. So, asymmetric encryption is used on a particular group of mathematical problems that are easy to compute in one direction but extremely difficult to reverse. In this context, extremely difficult means practically infeasible. So basically, if I want to decrypt something with RSA or ECC, right, it will take me, let's say, 100 years. Doesn't make sense for me to do it, right? Or it will cost me, let's say, billions of dollars worth of infrastructure to be able to decrypt this. So doesn't make much sense, and that's why it's almost extremely difficult to reverse and infeasible. So practically it's possible, but a return of investment as a hacker not needed. For example, we can rely on mathematical problems that would take a very long time, for example, millions of years to solve using today's technology. So with AI and quantum computing, that was the game. I want you to check, I think, Willow by quantum chip, right, could be a game changer in this game. Quantum chips are billions times or millions of times faster than a current server today. But there is no way to use them. There is no proper infrastructure, proper ways we can use them, so not used. We don't have to worry. We will visit various asymmetric encryption ciphers in the next room. For now, the important thing to note is that asymmetric encryption provides you, these things, you with a public key that you share with everyone and a private key that you keep guarded and secret. Summary of new terms: Alice and Bob are fictional characters commonly used in cryptography examples to represent two parties communicating blah blah blah. Should you trust DES? Lads, I would love to know the answers. I have given you too much explanation. I would love to know the answers. Should you use DES? And when was AES adopted as the encryption standard? I want some answers. I want some answers. Nay, yes, no. Thank you, sir. Thank you, good sir. Trust AES only. AES is the best. Sure thing. But what year AES became a standard was? Wrench. Which year AES became a standard? Okay, I think I'm not going to explain basic maths today because I think I have something better way to do it. But lads, Wrench, I'm waiting for your answer. Anybody else? I want to know, when was AES a standard? You need to know this. It's your history. I think you guys were born around that time. Right? So, another thing, right? I will give you, I won't go over task 6 today. 2001, yeah, thank you. But here's the thing, right? No, 2001. Actually, 2000s, what happened was 1999, DES was broken properly, right? So triple DES came into picture after that. But government realized it is all bullshit, right? So they said they came up with a proper, like a open competition, right? To come up with the algorithm. And so couple of good algorithms which you have even used today, right, were there. But only AES was selected as the encryption standard in 2001. So 1999, DES broke. 2000, triple DES comes out to be bullshit. 2001, AES came. Easy to remember. But also, one more thing I will tell you, right? The reason I won't go over task 6 today, I would love to. But thing is, I need to explain to you why only use HTTP, no HTTPS. Sure, buddy. Thank you so much for the kind words. HTTPS is insecure. HTTPS is insecure. Sure. I love you, man. I love you so much. You're a great guy. Okay, but I want to actually share something, right? I won't be going over the stuff today regarding the what's is called basic maths. Reason being, I understand XOR and modulo operation, why they are important and why majority of the algorithms just use these. So what I will be doing, I'll try to come up with some better way to explain them. I will have some examples, and so that you guys can do it and understand why these things are, and it also like stays in your brain forever. So I will do this I won't be there on Monday. I will be on Tuesday. So that will be your guys' Wednesday morning. Yeah. So instead of coming on, because I have gone on 17th and 18th, Crypto Hacks has the XOR. Oh, I need to check this Crypto Hacks, a free fun platform for learning modern cryptography. Ooh. Scoreboard. Canada or India, one of them, not here. And there's careers too. Oh, remote full time. Nice man. Okay, but here's the thing, right? I learned it from there. Oh, nice, dude. It will be nice. I will go over these crypto hacks. Because there are 3 of these, right? I'll show you something. So part of our cybersecurity 101 is these 3: cryptography basics, public cryptography, hashing, and then John the Ripper we will be looking along with Hashcat. There is one module on Hashcat, so we'll look on that. I don't think it's here. Maybe it's in the other one, but we'll look on that, right? Because it is a very good tool to use. But on Tuesday, when I come, right, we'll talk about XOR, the beautiful mathematical operation, gate, specifically a gate, and also modulo operation. Both are very useful to understand how and why cryptography is used, why it is used the way it is used, right? So, and why all of them use XOR or modulo type operations. Why not AND or OR? So I will go over that so it's easy, right? Because I need to come up with examples. I need to come up with some more information for you guys. No? Why not? Why not, my friend? Why are you sad? But okay, lads. I think this is what we'll do. On Tuesday, we'll cover task 6. Plus, we'll complete cybersecurity, the basics. No, XOR is best. Okay. XOR and modulo, yeah, XOR is the best. I can say that. But then also there is like a lot of these public ones which we'll see. This is a premium room. So we will start over this as well on Tuesday. Discover how public key ciphers such as RSA work and explore their role in applications such as SSH. Big, right? And I have some history about PGP. I'll share a bunch of good history I have to share. This is my realm. This is my G. This is my thing, right? So I'm going to go over these, right? And I will share a lot of good info. This will be a history plus politics plus just everything. Your history part, right? How you are affected from this is also this. So hopefully you guys enjoyed the today one, right? Happy Janmashtami to everyone, right? Especially my friends in India and everyone, right? All the Hindus, my Hindu brothers and sisters. But with that being said, lads, thank you so much for joining me today. It has been a pleasure being your favorite uncensored hacker with a very surprising name for an uncensored person called Censored Hacker. Signing off for today. Feel free to join the Discord, right? Don't forget to join the Discord because if there's a lot of good people there. Some just killing it like Wrench and Rabbit, giving everybody a hard time with their Hack the Box ranks. But yeah, thank you so much, Wrench, and thank you so much for everyone for coming. And I'll see you on Tuesday with some exciting new stuff to learn. Till then, thank you so much. Have a good day. And like usual, bye. Bye everyone. Love you. Thank you so much. And Radhe Radhe. Bye.